My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 276. In this lecture, I will continue my discussion on decision surface for KNN, that is K nearest neighborhood algorithm. Just let me recall what we discussed in lecture number 275. What I discussed in this particular lecture, in KNN, the smoothness of decision surface the smoothness of decision surface increases as k increases, isn't it? That's what I discussed in my previous lecture, that is in lecture number 275. Now let's take an extreme case. We will consider an extreme case. Let's take an extreme case. You understand machine learning better. By playing things like this. Our deeper understandings, our deeper understanding comes by understanding the concept either mathematically or geometrically. I will repeat. Our deeper understanding comes by understanding the concepts either mathematically or geometrically. We prefer geometrical interpretation because it is easier to understand. Now let's say k equal to n. Worst case, I can say this is worst case. K can be equal to 1. Your k can be, let me write like this, k can be 1, 2, 3, so on. What is the maximum value of k is n, isn't it? As we went from 1 to so on n, my curve becomes smoother. What happens when k equal to n? That is the extreme case. That's the largest possible value of k, isn't it? What is n here? N is, what is n here? Total number of points. Total number of points. What is n here? Total number of points. Then what happens? This is extreme case. Understanding extreme cases helps us in deeper understanding of what's happening. I strongly recommend any concepts in mathematics, especially in machine learning, you can understand by considering extreme cases. Here k equal to 1 is one extreme case. Let's assume in my data set I have n points. What are the number of points in my data set? Let's assume in my data set I have n points. Let me assume there are n points in my data set. In these n points, let me assume n1 points which are positive. N1 points are positive points, and n2 points which are negative. Let me say your n2 points are negative. Of course, it is not necessary that 50% of the points are positive and 50% of the points are negative. If you recall our Amazon review dataset or Amazon fine food review dataset, just if you recall it, only small percentage of them are negative and most of them are positive. Of course, your N1 plus N2 equal to N. N1 is, what is my N1? N1 is number of positive points. This is number of positive points. What is my N2? N2 is number of negative points. If I add them, I will get total number of points in my data set. Let's assume N1 is greater than N2. If N1 was, let me keep some numbers. Let me assume N is 1000 points. N is my total number of points. Let's say N1 is 600 points. My N2 is 400 points. Obviously, N1 is greater than N2. Why? Because your 600 is greater than 400, isn't it? I am creating just an example here to understand what happens when k equal to n. When k equal to n, what happens? Let's look at geometrically. So imagine I have data set like this. Just let me consider the data set which I discussed in my previous lecture. This is the data set which we discussed, isn't it? Let me say, what is this case? Case is k equal to n. What is my n1? n1 is set of all positive points. n2 is set of all negative points. Here n1 is greater than n2. Now what happens? Take a query point. Let me take one query point. Let me take query point here. This is my query point. Let me assume this is my query point. As I told you, just assume n equal to 1000. I have 600 positive points and 400 negative points. Let it be. Now I am going to take 1000 neighbors. For this query point, I must collect 1000. I am going to take 1000 nearest neighbors. When I say 1000 nearest neighbors, all my points will come. Now what happens? This is first nearest neighbor. This is second nearest neighbor. In that manner, for this particular query point, how many nearest neighbors I will get? I will get 1000 nearest neighbors. In those 1000 nearest neighbors, what I have to do? I have to take majority voting, isn't it? If I take majority voting, as n1 is greater than n2, therefore this particular query point will get positive sign, isn't it? What sign will it get? It will get positive. It is positive sign. It is a positive point. Why? Because you are getting 1000 neighbors. In those 1000 neighbors, 600 are positive points, 400 are negative points. So what's happening right now? This query point will be called as positive point, as there are more number of positive points. Because I have more positive points, according to majority voting, this query point will get positive sign. Now comes the worst part. If my query point is deeper, somewhere here, just take here. Take how many neighbors you will get? Again I will get 1000 neighbors. Again I will get 1000. I will get 1000 nearest neighbors. Still I will get 600 positive points, and in those 1000, 400 negative points. According to majority voting, this particular point will be assigned positive sign, isn't it? 1000 basically means all the points. Since I have more positive points, we will get 600 positive points and 400 negative points. Since there are more positive points, this query point is also positive. So wherever the point is, take any query point in this data set and identify the 1,000 neighbors. That particular query point will get positive sign. Why? Because there are more positive points. Wherever my query point is, my 1,000 nearest neighbors will say everything is positive. There is no more decision surface. Everything is positive because I have more positive points in the data set than negative points. So with this worst case, what that happens when k equal to 1? When it happens when k equal to n? It is important to understand. Now we will see since we understand geometrically, one thing we should understand: as k increases, my curve gets smoother and k becomes n. Whatever is the majority class here, since I have more positive points than negative points, everything becomes one class. Everything will become one class. This observation is important when k equal to n. That is one class in the sense I can say majority class. According to majority voting, all query point will get that majority class label. What is the majority class? A class which has more points. If you have exactly same number of points in those 1,000, if you have exactly 500 positive points, if you have 500 negative points, then algorithm will say I don't know what to do. I don't know what to do, isn't it? It is completely indecisive. It cannot take decision. That's what happens geometrically. With this geometric interpretation, with this particular geometric interpretation, we will learn how to find. Our intention is, with this geometrical interpretation, we will learn how to find right k. How to find right k in my future lectures. Just time being, understand this extreme class so that in my next lecture I will discuss about a beautiful concept in machine learning is known as overfitting and underfitting. We will try to understand this concept. Then after few lectures I will explain how to find right k in KNN. Thank you very much.